Okay, so we're going to the next page. So here is 7 through 9 you can check. You're still there, Nathaniel? There you are. Thank you. And then for Kayla, Diego, Devin, Calvin, if you're able to turn on your videos, this would be the time to do so.
I'm here.
Thank you. Okay, going down so you can see number 11. Okay, I'm gonna go to the next page. Can you speak up now and say still checking if you need me to leave this up longer, and make sure your mic is turned on if you need to say that you're still checking. Okay, we're gonna go to the next page then. So here is 12 through 15, or 13 and 15 are up here. And please don't forget there will be a final. I'll give you more information on that later, but we're not going to have any full tests. We'll probably just have like little mini quizzes as we go, and then we'll have a final sometime mid to late May. So just keep that in mind. So it's important that you're asking questions just like normal if you don't understand something or just needs more clarification. And please, as a reminder, remember that there are often more than one way you could solve these problems depending on what you're solving for first. So like on number 15, you could solve for any of the three angles first step. You don't have to solve for angle A at the beginning. Okay, going down to 16 and 7. I guess, did I give you enough time for 16 and 17? Look at that, maybe 10 more seconds. Let me know if you need more time.
Mr. Moore.
Okay, going to the last, yeah.
What was the extra credit for today for the Zoom meeting, or was there not any?
There will be, I just haven't announced it yet.
Okay.
Okay, so number 18 is a little trickier one, just because you have to use law of cosines on multiple steps. So you first have to solve for 13.9, and then use that answer to solve for 12.9, and then use 12.9 to solve for x. So this one you have to use law of cosines multiple times. So you need to know 12.9 before you can solve for x, and you have to know what the side with the 13.9 before you can get the 12.9. All right, so I'll take any questions you have on 17.3, homework out of the textbook. Any questions?
Can you do
on
number 7, please?
17.3. Number 7, yes. Look at number 7. Is anyone still checking number 18? Problem number 7. Okay, so if it's out of the textbook, I don't have the blank document, but I can still work through it. So looking at number 7, if I know 3 sides, I can solve for any of the 3 angles. First step, it doesn't matter. So if I want to solve for angle P first, I would just say that this would be little p. This would be little r, opposite big R. This would be little q, opposite big Q. So the formula I'm going to use here is that p squared equals, and it's r squared plus q squared. It starts off looking like Pythagorean theorem, but then you times the 2 sides you just used, r and q, and you multiply that by cosine of the angle opposite this side that's by itself. So opposite little p is going to be big P. Okay, so now I'm going to plug in what I know here. So I know little p is 3. I need to mute Madison. Okay, so little p is 3 equals little r is 6, and then little q is 7 minus 2 times 6 times 7 cosine of p. So this becomes 9 equals, this is 36 plus 49. So when you do 36 plus 49, that's going to give you 85. When you multiply these 3 numbers, 2 times 6 is 12, 12 times 7 is 84. Please do not combine the 85 with the 84. You have to subtract 85 to both sides. So when you subtract 85 to both sides, you're going to get negative 76. Equals negative 84 cosine of p. Negative divided by a negative is going to be a positive. So I have 76 over 84 equals cosine of P. And then to solve for P, it's going to be the inverse cosine of 76 over 84. So make sure you are in degree mode on your calculator. You would plug that into your calculator, and that's going to give you 25.2 degrees. So I'd say the measure of angle P is approximately 25.2 degrees.
Does the angle we always find, does it always have to be like does it matter which one you start off with? Because I started off with
No, you could have started off with Q or
and
R.
you,
It doesn't, for this problem, it
okay.
doesn't matter.
Okay. I saw my mistake. Thank you.
Did that answer your question?
Yeah, I understood. I
Okay.
just like a thank you.
All right, so questions on 17.3.
$18.
Okay, so I'm going to switch over to, oh, you said 18?
Yeah.
Okay, so let's look at 18. Yeah, 18 was just kind of long because for 18, let's see. So on 18, you'd have to do law of cosines. You'd first focus on, I'm probably, if you have a specific question, you can let me know, but I'm just gonna talk about, so you'd first focus on this here. You would do law of cosines to solve for 13, to get 13.9. And then after this step, you would do law of cosines again using this triangle. So now that you know what 13.9 is, you can use law of cosines to get 12.9. And then you'd have to do law of cosines a third time. Actually, they would be a second time. So you do law of cosines to go from the green to the blue, and you do law of cosines again to go from the blue to the red. So you'd have to do law of cosines again to solve for x right here. Was that okay for 18?
Oh, yeah, it was okay. Okay.
Okay, so as long as you're okay with law of cosines, that one's just a little bit longer because you have to do law of cosines twice there. I don't think I have enough room to.
Thank you, Mr. Morrison.
No problem. Okay, any other questions before we move on? All right. Now we're going to 18.0. And remember, this is the section that we're going to have a mini quiz on Thursday. So this is 18.0. So like I said, you might, if you need to make a note, I'll probably be sending out, my goal is to send out an email once a week, but it doesn't look like that's going to happen. So I'll be sending out another announcement on Google Classroom sometime later today, probably this evening, with that information included in it. So 18.0 quiz, and then talking about the scheduling. Yeah, it's kind of sad that after this week, we're only doing 2 assignments per week. Oh well, we'll get through it together. I guess I can't say every week, but probably most weeks we'll be doing 2 assignments. Okay, for worksheets, I can go to a blank copy after we're done checking. Okay, so going down, so you can see 5 through 8 here. I can always go back if you need me to go back. So we're going down to 5 through 8. All right, moving on to the next few problems. Here is 9 through 12 coming shortly. Little lag there, but 9 through 12. Through 16. All right, so let me get back to 15 through 16, or 13 through 16. Okay, so I'm going to take questions now on 18.0.
Mr. Morrison, could you do 16?
16, yes, let's look at 16. So I'm going to go to a blank one so I have more room. Okay, so it's 18.0. Okay, so number 16, in your notes from Wednesday, I gave you a formula for an equilateral triangle. So the area of an equilateral triangle is going to equal the side length squared, so s squared times radical 3 over 4. And we proved that in the notes from Monday. So in this case, our side length is 10. So I can plug in 10 here. So it's going to be 10 is my side length times radical 3 over 4. So this is going to equal 10 squared is 100 times square root of 3 over 4. And then when you do 100 divided by 4, that's going to give you 25. So this would be 25 square root of 3 in its area, so it's square units. So I'm going to do square meters. So is that all right for number 16?
Yeah, thank you.
Mm-hmm. Other questions? It's a small group today. I'm guessing a lot of people are in history, which is fine. I don't feel bad. I know I'm taking up history's time. Just, like I said, scheduling conflicts and other factors involved. We had to keep it the same this week, but next week we'll be on block schedule.
Yeah, I'm doing 2 meetings at once right now.
Oh, that's impressive, Heba.
Thanks.
2 different Zoom sessions. See, that's an overachiever right there. Okay, so last call. Any questions on 18.0, which the quiz is going to be on Thursday, the mini quiz? All right, so we're going to switch to notes then. So everyone hopefully has their note packet on them that I gave you the last day we had class at Etiwanda High School. So like I said, I keep saying this, but yeah, next week is not going to be this much. I know we've started off kind of doing a lot, but that's going to allow us starting next week to kind of take it, not be as much to cover going forward. Okay, so bringing the notes up here. So trig notes. So we're going over 18.1a. So we're talking about circles. Angles of rotation. Okay, so I'm going to start with angles of rotation that you should know. Just a quick word before we get started with this. A lot of what we're doing, obviously, it can impact your grade, and that should matter. But what should also matter is making sure to get you ready for honors pre-calculus, because these are things you're expected to know when you step in day 1 to honors pre-calculus. You should know angles of rotation and radian measures and a lot of the other things that we're going to be doing for the school year. Okay, so this is called the unit circle. So I'm going to start here. This is 0 degrees. So actually, before I get started, I'm going to highlight. This is called the initial side, is the positive x-axis. So initial means where we're starting. So when you're going off of the unit circle, you always start at the initial side, which is the positive x-axis. Okay, so then hopefully it'll come up here in a second. I'm assuming it will, and it's just slow. I want to keep writing, but it's not displaying it. I can see it on one screen, but not the other. Okay, maybe I will unshare and share it again if it doesn't come up. Okay, for some reason it's not coming up. So let's pull it back up here. There it goes. Okay, bear with me here. One of the challenges of distance learning, dealing with technology. which doesn't always come through when you need it to. Okay, so I'm highlighting initial side. I'm hoping it's going to work this time. Which is the positive x-axis. Okay, still lagging, but at least it's coming up now. So initial side is the positive x-axis. Okay, so this is where you start. So this would be, if you're on the positive x-axis, that's a 0 degree angle of rotation. The next one that we're gonna look at is 30 degrees. These are all based off of special right triangles that we did in the previous lesson. So 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so that's quadrant 1. So 0, 30, 45, 60, and then 90. Now I'm going into quadrant 2. You see the Q stands for quadrant. So you guys have all learned the quadrants before, right? So quadrant 1 stands for quadrant 2, quadrant 3, and quadrant 4 using Roman numerals. So when I continue into quadrant 2, it's going to be 135 degrees, then 150, then, wait a second. Oh, I skipped one, sorry. Let's see, backtrack. I skipped 120. So 120 degrees, 135 degrees, 150 degrees. And when you're halfway around the circle, you guys know that's 180 degree rotation. These are all angle measures inside a triangle. Okay, so now we're in quadrant 3. So this is going to be 210 degrees, 225 degrees, 240 degrees, 270 degrees, and we have 300 degrees, 315, 330, and another way to say 0 degrees is 360 degrees. If you go all the way around the circle, you're back to where you started. So 0 degrees is equivalent to 360 degrees. Okay, so now I'm going to talk about the terminal side. So the terminal side would be like, I'm just giving an example here. So the terminal side could be anywhere. The initial side is always the positive x-axis. The terminal side, let's say the terminal side is right here. That means this angle is formed here. That's a 135 degree angle.
I'm in my math class.
Yaz means having fun. All right, so that's a 135 degree angle if we're using a terminal side at 135 degrees around the circle. So that's how angles that you learned in IM2 using two sides are related to angles of rotation around a circle. So if the angle creates a 135 degree angle, it corresponds to a terminal side on the circle, which is also 135 degrees. All right, so any questions before I go down? Okay, so I'm going to clear this off and then go down. So now we're going to look at drawing angles of rotation. So I'm just going to start off by highlighting the initial side. Hopefully you guys can still hear me. I haven't heard anything in a while. Actually, can someone turn their mic on and say yes if you can hear me?
Yes.
Yes.
Yep.
Yes.
It's been so quiet lately. I wanted to make sure everyone's still there.
We're good
It felt weird how
listeners.
quiet it was. You're good listeners, that's true. Okay, so here I'm going to always start with the initial side, which is the positive x-axis. So this will always be your initial side. The side that changes is the terminal side. So if you want to do a 150-degree angle of revolution, or also called angle of rotation, if you were to go right here, that's going to be 90 degrees. And then you would have to add another 60 to get to 150. So it's going to look like this. So this is going to be the terminal side here. So the terminal side would look like this. So this would be a 150-degree angle starting from the positive x-axis. So you go 60 degrees, I probably maybe should have gone a little further, but 60 degrees beyond the positive y-axis. So to do 300 degrees, every time you hit an axis, you've got 90 degrees. That's 90. Let me wait, still a little lag there. It's hard to do with the lag. So that's 90, and then 180, and then 270. And then you go another 30 degrees. So this is going to make your angle of rotation. And so you draw the other angle from the origin through the red arrow. So that's going to be a 300-degree angle of rotation.
Is there a
also,
reason why we have to put the arrow?
The arrow just shows you the direction that you're going. Because you started at the positive x-axis, the arrow tells you where you end up.
Okay.
Okay. Also, if you notice, I always start. Because these first three examples are all positive, I'm starting going counterclockwise up from the positive axis. Same thing on 710. So if you want to do 710, this is 90. Come on, I'm tired of this lag. This is hard to do with the lag. If I draw it, then I have to wait like 10 seconds for it to come up. There it goes. So 90, 180, 270, 360. You just keep adding 90. So 450, add 90 again. So that's 540. 630. And then to get to 710, you have to add 80 degrees to 630. So you're not going to quite make it to the axis because you're stopping 10 degrees short of 720. 720 is twice around. So this is how you have to show this entire thing when you're drawing a 710-degree angle of rotation. So right here, your terminal side is going to be in green. It's going to look like this. Okay, so remember we're drawing angles of rotation. We're starting at the positive x-axis, which is the initial side. And then we're using the given angle to figure out where to stop. So the next one is going to be negative. So instead of going up from the positive x-axis, we're going to go down. So we're going clockwise now. So right here, so going clockwise, that's how the negative is going to affect it. Instead of starting going up from the positive x-axis, I'm going to go down from the positive x-axis. So I'm going down. Every time you hit an axis, you're moving 90 degrees. So that's going to be down 90. This would be negative 180. And someone turn their mic up and tell me, what do you add to 180 to get 225?
45.
45 is correct. So 45 is halfway into the quadrant. So when I draw my terminal side, it's going to start at the origin and go through the red arrow. So it's going to go like this. So this would be a negative 225 degree angle of rotation. Also, I'm just going to quickly indicate which quadrant all of these are in. So this one is in quadrant 4 if it stops in the bottom right. This one is quadrant 2. So use Roman numerals for quadrants. So quadrant 2, this one is in quadrant 4 again, because you're in the bottom right where it stops. This one stops on the top left, so here you're in quadrant 2. So any questions before we wrap up this page? I know we still have more to do, but any questions so far? Okay. So let's look at 300 degrees. We want to find coterminal angles with 300. Coterminal just means it's the same terminal side. So if you want to get an angle that's coterminal, you can either add or subtract any multiple of 360. Equals 660. Their question, Ethan?
Yeah, how do you know like at what angle to draw the green arrow, it seems?
We just start at the positive x-axis, and then you just, every time you hit another axis, you add 90 degrees, and then you have to get to that number that's given. So like if you're doing 300, it would go, don't write this, but it would go 90, 180, 270. So you'd hit 3 axes, so 90, 180, 270, and then you have to add 30 degrees to that to get to 300.
Okay.
So that's a 300 degree angle of rotation. 360 would be all the way around.
Okay, that makes sense, I suppose.
Okay. So let me get rid of that. Okay, so then over here, if you want another positive coterminal angle, you just take 660 and then you add 360 again. So this is going to give you 1020. So all 3 of these angles have the same terminal side, the same green arrow. It's asking for 2 positive and 2 negatives. So if you want to get negatives, you take 300 and you subtract 360. If you have a question at any point, you could just turn your mic on and let me know. That's fine. This is 60 degrees. And if you want a negative coterminal angle, you can take negative 60 and subtract 360 from that. So again, all of these have the same green terminal side. These are called coterminal angles when they have the same terminal side.
What does it mean to have the same terminal side?
That just means the green arrow from the, see the 4 graphs on the left? So the green arrow would be at the same place. So like 710, if you were to subtract 360 from that, the green arrow would still be at the same place. So like 710, I would do 710 minus 360. That's going to give me 350 degrees. Look like that. So it would go right here. It would still have the same green arrow. If you were to, if I told you, even though you only go around, you don't go around as much, it would still stop at the same place. So it has the same terminal side. Is that okay?
Yeah, thank you.
Okay. Mm-hmm.
Mr. Morrison, real fast, could you quickly show like apparently the unit circle above? I didn't get to copy that down.
That is, I don't have that anymore. You could get it from someone else, or also my plan is later this evening to send out the video, so you could just probably quickly find this by,
Oh, okay.
yeah, but if you have someone else, I'd have to rewrite everything again.
No, that's fine. Thank you.
Mhm.
Mr. Morrison, where'd you get the -60?
-60 came from this previous answer, so -60 degrees. So because -60 is coterminal, so if you subtract 360 from that, it's still going to be coterminal. Okay, so now for the next one, -225. I'm going to try to find two positive coterminal angles, so I'm going to add 360. So that's going to be 135. So this would have the same terminal side as -225. And if you take 135 and you add 360 again, that'll give you another positive coterminal angle. So this is going to be 495. So all three of these angles have the same terminal side. Even though when you draw them, they might look a little different, the terminal side is in the same location. Actions up here, two negative coterminal angles. You can take -225 and subtract 360, or any multiple of 360. So this is going to give us -585. And then I take -585. I subtract 360 from that. That'd be a second coterminal angle that's negative. So -945. So now we just found four coterminal angles with all have the same, even though the drawing of the picture would look a little different. Okay, any questions before I clear this out? Okay, so I'm going to clear out the screen. Before I go to the next page, I want to do a quick intro to what is a radian. Remember I told you on your calculator, make sure you're in degree mode. So today we're going to be talking about radians. When you get to AP Calculus, everything we do is in radians. You're not working with degrees anymore. Pre-calc, you'll still be working with both degrees and radians. Okay, so let's talk about what is a radian. So a radian is, let's say you have, I'll just use one of these graphs here. Okay, so if I was to draw a circle, and for a circle, it has a radius of length r. So I'm going to call this r. You don't have to write this down. I just want you to know what it means when we talk about a radian. If you were to take the radius and you were to bend it so it fits around the circle, it might look something like this. Take the radius and bend it. It might look like that. That's called 1 radian. You just take the radius. Imagine the radius was a string. Couldn't you curve the string along the circle? So that would be called a radian now. So you take the length of the radius of any circle and you just sort of bend it. Think of the radius as a string. And you just bend the string so that it fits along the circle. Well, every circle, let me backtrack here. Every circle has a circumference of 2 pi r. So that means you take this radius, this is also r here, and there's going to be 2 pi of those. Isn't 2 pi pretty close to 6? It's 6.28, right? I'm just going to round it. It's about 6. So that means every circle has about 6 of these that goes around it. So if you take the radius and you curve it, there's 1, 2, 3, 4, 5, and 6. So if you take a radius, you'll have 2 pi of those, so about 6.28. I'm just going to make it simple. I'm going to say it's about 6. So it's about 6 times. If you take 6 radii, plural for radius, you would pretty much make it all the way around the circle, for every circle in the world. So that's 1 radian would be a radius when you curve it. Okay, so I'm going to move to the next page now. We're going to talk about radians. So we said if 2 pi r gets you all the way around the circle for the circumference, then 2 pi radians is the same as 60 degrees. Half a circle is 180 degrees, so that's pi radians. So you take about 3 radians to get halfway around the circle, 6 radii the way around the circle. So when you're thinking about not what fraction of the circle you're working with, you're talking about a distance around the circle, how far you're traveling. So to convert from radians to degrees, you always multiply by 180 over pi, because 180 degrees is the same as pi radians. So 180 over pi, you're just doing something divided by itself, which is just 1. So when you multiply by 1, that doesn't change the value. So for this first one, I am going to, still feel so quiet in here. It's okay to ask questions if you guys have questions. Don't be shy. Still kind of like a small group, and a lot of people are missing today. So 2 pi over 3 times 180 over pi. So the pi's are going to cross cancel. The 3 becomes a 1, the 180 becomes a 60. So 2 times 60 is going to be 120 degrees. So if I said 2 pi over 3 radians, that's the same as 120 degrees around the circle. You're doing 2/3 of a half circle. So 2/3 of 180 is 120. So for 7 pi, you're doing 3.5 times around the circle. Every time you do 2 pi radians, that's once around the circle. It's important that, especially going to pre-calculus, you train your mind to start thinking in radians. I know you've used degrees for your large chunk of your life, like 360s and 720s and 1080s and things like that. But you want to start thinking in terms of radians next year. So 7 pi times 180 over pi. So here the pi's are going to cancel out. So 7 times 180 is 1,260 degrees. This is 3.5 times around a circle. Okay, whenever you're converting from degrees to radians, you multiply by the reciprocal of 180 over pi. So now you're timesing by pi over 180 to get from degrees to radians. So it's going to be 390 times pi over 180. So here, I'm going to divide the top and the bottom by 30. So divided by 30 is 13. If you do 180 divided by 30, it's going to be 6. So if you don't put the degree symbol, the little circle up high, I assume you're talking about radians. So you could write the word radians, but just as long as you don't put the degree sign, that's fine. We're assuming we're talking about radians when you don't see the little degree symbol, the little circle on the top right. So 720, you would also times this by pi over 180. So 720 over 180 is just 4. So 4 pi radians is the same as twice around the circle. So 2 pi is once around, 4 pi is twice around. Okay, any questions before I clear this? Actually, I'm not going to clear it. But any questions though? Okay, so I'm going to move to the right, coterminal angles. Instead of adding or subtracting multiples of 360, now I'm going to add or subtract multiples of 2 pi because we're working in radians. Pi, which would be 3 pi. This is coterminal to pi. It has this same terminal. Then you could do 3 pi plus 2. And you want to get 2 negatives, so 2 positives and 2 negatives. So to get 2 negatives, you can take pi and subtract 2 pi now. So I'm going to take pi and I'm going to subtract. Give me a lag here again, not sure why. Negative pi, subtract 2 pi from so all 4 of these angles that I listed that you haven't seen yet, it's trying to get there. So all 4 of these angles are coterminal with pi. Okay, for pi over 2 now, I'm going to let 2 pi equal 6 pi over 3. Just as, 4 pi over 2, sorry. So if you notice, I have a denominator of 2 here. So to get a common denominator, instead of adding and subtracting 2 pi, I'm going to add or subtract 4 pi over 2. Okay, so what this is going to look like, I would take pi over 2. Then I'd add 4 pi over 2. So it's going to get 5 pi over 2. Will come up eventually. It's just a little slow. So then I take 5 pi over 2. I add 4 pi over 2 to that. And that's going to give me 9 pi over 2. And to get 2 negative coterminal angles, I'm going to be subtracting 4 pi over 2. So I'm going to take pi over 2, subtract 4 pi over 2. That's going to give me negative 3 pi over 2. And then I'm going to take negative 3 pi over 2 and subtract 4 pi over 2. And this is going to become negative 7 pi over 2. Okay, so I'm just, instead of adding and subtracting multiples of 360, like we did with degrees, now I'm using the fact that 360 degrees is the same as 2 pi. So I'm adding and subtracting multiples of 2 pi to find the coterminal angles. But for the second one we did, instead of 2 pi, I just used 4 pi over 2, so I have a common denominator. So any questions so far before I clear the screen out? You guys are still there?
Yes.
Yeah.
We're
Okay,
working.
thank
Yes.
you. I get nervous when I talk for like 10 minutes and I don't hear a sound. I think I lost you or like my internet's down or something. Okay. All right, so I'm gonna go to the bottom. So last call, any questions before I clear the screen?
So for today's calculator, do we have to put it back to radian or?
No, we're not. For this lesson, we're not really using
Calculators?
we're not using calculators for radian mode.
Okay.
You can still use calculators, but you don't need to be in radian mode for this lesson.
Mm-hmm.
You only do radian mode when you're doing like sine, cosine, or tangent, something like that, and it tells you to use radian mode. Okay, so clearing the screen. Okay, so this is an important formula here. So this is a track question. If anybody does track, I think Lena does track. There might be more people.
I do track.
Oh, Ruben, you do track too? Soccer and track?
Yeah. And cross country.
You're a busy guy. And cross country. So you're going all year, huh? You never get a break. Okay. So right here, for anyone that does track or is interested in track, or even anyone that's not interested in track. So how this is going to work is on a track, you have an inside lane and you have an outside lane. So I'll start with the outside. So let's pretend this is the outside lane. Well, that was a pretty good circle. Let's say this right here is the inside lane. It says you have a track coach standing at the center of the circle. So right here is your coach. So right here it says let's see, he watches them run in a 120-degree arc. So 120 degrees, that's 1/3 of a circle. It's 1/3 of 360. So 120 degrees. I'm just going to try to estimate 1/3 of a circle. So about right here. And this would be 120 degrees for the small circle. So next I'm going to draw his field of vision. So he's looking right here. So he's looking this way. He can see, he watches them run at 100 degrees. So it looks like this. So runner A is in the closest lane. So I'll say runner A is right here. And then runner B is in the farthest lane. So out here it would be runner B. So you can see that even though, this is why radians are important, even though A and B are both running 120 degrees, person B has to run because they're in the outside lane if they're covering a 120-degree span. So it says person A is 200 feet from the coach. So this distance right here is 200. And then person B is 220 feet. So this distance to B is the same as over here. So I'm just going to do it over here. So this is 220 feet. Just so I don't have to overlap them. So this is 220. How much further did runner B run than runner A? Okay, so using the highlighted formula at the top. So length of the arc. So I'm going to say length of arc. I'll start with arc B. So this is what arc B is running, or for person B is running further. So they're running using the formula. For the big circle, the radius is 2. So that's going to be the radius here. Times the radian measure. So the radian measure is going to be, I'm going to convert 120 degrees to radians. So it's 120 times pi over 180. So when you reduce 120 over 180, it's 2/3. So this is 2 pi over 3. So when you use the formula, you have to times by the radian measure. So I'm going to do 220 times 2 pi over 3. When you figure out that value, that's going to be 440 pi over 3 feet. This is how far runner A is running. 440 pi over 3 feet. I probably shouldn't box this because that's not the final answer. So now I'm going to find the length that runner A is running for 120 degrees, 1/3 of the circle. So length of arc A, meaning it goes with runner A, this is going to be 200 is now the new radius of the small circle. You times this by 2 pi over 3, which is the same radian measure, 120 degrees. When you figure out what this is, that's going to be 400 pi over 3 feet. So what we've done so far is we figured out how far runner B ran and how far runner A ran. And the question is saying, how much further did runner B run than runner A? So that means I take this number and subtract this number, and that's my answer. So we figured out how far both of them ran. So if you want to know how much B ran, subtract how far runner B ran, or do that minus how far runner A had run. So it's going to be 440 pi over 3 minus 400 pi over 3. So this is going to give me my answer, which is 40 pi over 3 feet. So
Wait,
that's
where'd
a
you
little
get the
bit.
sorry? Where'd you get the 2 pi over 3?
The 2 pi over 3 came from my scratch work right here. I was converting 120 degrees.
Oh,
I was converting that to radians. So to
okay.
convert 120 to radians, I just times it by pi over 180.
Oh, okay. Thank you. To get it to radians. Yeah.
To use this formula here for arc length, you
Uh-huh.
have to be working with radians.
Okay. That makes sense. Thank
So runner B actually runs an extra 40 feet, even though they're both running 120 degrees of their circle. Because B is in the outside lane, B has to run quite a bit further. Okay, so any other questions on this one?
Wait, how do you know that it's 40 feet? Shouldn't it be like whatever the 40 times pi divided by 3 equals?
Where did you get 40 feet?
Because you said that the runner B had to run an extra 40 feet, but
I just thought of pi is pretty close to 3. So I just kind of canceled out the 3's. So it's about 40. It's a little bit more than 40 feet.
oh, okay.
Yeah,
Oh.
so I was just estimating this in my head. It's going to be a little bit more than 40 feet.
Yeah, that makes sense. Sorry.
Yeah, that's okay. No, that's a good question. I was just in my head thinking pi is pretty close to 3. So then I just canceled out the pi and the 3.
Okay, thank you.
All right, for this last one. Is this the same directions as we find 2 positive coterminal angles and 2 negative common denominator. So rather than adding and subtracting 2 pi, I'm going to be adding and subtracting 6 pi over 3, since my denominator is 3. Okay, for this one, it's going to be to get, if I do negative 11 pi over 3, if I add 6 pi over 3, this is going to give me negative 5 pi over 3. So it actually, even though I added 2 pi, it was still one of my negative angles. So that means I only have to find one negative angle later. Maybe I'll just find the other negative angle now. So I would take, well, no, I'll find 2 positives. So negative 5 pi over 3 When I add 6 pi over 3 to this, that's going to give me pi over 3. And then when you take pi over 3 and you add 6 pi over 3, that's going to give you 7 pi over 3. So right here, these are my two positive coterminal angles. I need to find one more negative because it asks for 2 negatives and 2 positives. So I'm going to take negative 5 pi over 3. Actually, no, I don't want to do that. I'm going to take negative 11 pi over 3, what I started with, and I'm going to subtract 6 pi over 3 from that one. Because if I took negative 5 pi over 3 and subtracted 6 pi over 3, that would give me the given angle. I want a different angle. So I'm going to take negative 11 pi over 3, subtract 6 pi over 3, and this gives me negative 17 pi over 3. So this gives me 2 positives and 2 negatives for a total of 4 coterminal angles. Okay, any questions here? Everyone's okay so far? Before we move on to something else? I know it feels like a lot. After this week, it's not going to feel so overwhelming. But yeah, part of why we're doing this week is this allows us to slow down afterwards. Okay, no other questions right now? All right, so for the extra, we still have more to do, so we're not done. Let me see, but for the extra credit today, what I'm gonna have you do is take a picture of a thumbs up. So like hold your hand about a foot away from your phone so I can clearly see a thumbs up because we're doing math, so that's a good thing. So and you would just upload that picture on the Zoom extra credit for April 6th. That has to be done in the next few minutes to get the extra credit. So right now, while before I transition to the next page, just take a picture of a thumbs up and I make sure I can tell that it's a thumbs up so you can get the extra credit. And then upload that, make sure to hit turn in when you submit that on Google Classroom. So do that now. All right, so any questions before I clear the screen and move on to 18.1b, which should be faster than 18.1a. Everyone's okay? All right, so I'm gonna clear this out. So remember on 18.1a, we started off focusing on degrees. Now we're slowly transitioning into radians, which are critical that you have a good understanding of radians going into pre-calculus. Okay, let's see here. So clearing this out. Hopefully everyone's able to submit the extra credit. Okay, so here's the unit circle again. Unit circle, I haven't talked about this, but it just means it has a radius of 1 unit. So we'll talk more about that later. You don't have to stress about that. So this one has the quadrants labeled. So now I'm going to label 30 degrees is the same as pi over 6 radians. When you guys remember how to convert? So you just take the degree measure and you times by pi over 180. But you're going to be using these so much in pre-calculus, you're going to need to memorize them, because I know the honors pre-calculus teacher isn't going to give you enough. He's going to time your quizzes, and you're not going to have enough time to sit there and convert all of these. So you need to know these. There's a lot of patterns on here, which we're going to talk about. But 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. 90 degrees is pi over 2 radians. So we just took care of quadrant 1. Now we're going to move into quadrant 2. So 120 degrees, that's 2 pi over 3 radians. 135 degrees is 3 pi over 4 radians. For 150 degrees, that's 5 pi over 6 radians. For 180 degrees, that's just pi radians. So pi radians of a circle. So now we're entering quadrant 3, the bottom left. So for quadrant 3, we have 210 is 7 pi over 6 radians. 225 is 5 pi over 4. And then 240 is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 pi over 3. 135 is 7 pi over, I'm sorry, 315, not 135. 315 is 7 pi over 4 radians. 330 degrees is 11 pi over 6 radians. And 2 pi is the same as 0 radians. Like 0 degrees is the same as 360. So 2 pi radians is the same as 0 radians. It has the same terminal sign. So this is your unit circle in radians. All of these angles are based off of special right triangles, which we'll be talking about more soon. Probably not so much today, though. Just a couple of cool patterns. If you take any diameter of the circle, see how they have the same diameter? Or sorry, the same denominator? The diameter, if you draw any diameter here, the denominator is going to be the same. So like right here, I'll give an example. This would be a diameter. Oops. If you look at both ends of the diameter, they have the same denominator. That works for any diameter. The radian measure is going to have the same denominator. So in this case, it would be 6. Some other cool things about this, if you look in quadrant 2, the denominator is always 1 more than the coefficient of the numerator, like 2 to 3, 3 to 4, 5 to 6. Quadrant 3, it's always 1 more than the denominator, 7 over 6, 5 over 4, 4 over 3. And then in quadrant 4, if you double the denominator and subtract 1, you have the coefficient of the numerator. So like, if you focus on this one here, 2 times 6 is 12. 12 minus 1 is 11. That works for all 3 of these. 2 times the denominator, and then if you subtract 1, it gives you the coefficient of the numerator. So a lot of patterns going on here. Those are just, I just named a few of them. But you are going to want to put this to memory at some point. I'll have you fill out a blank. We're not there yet, obviously. Okay, I want to talk about reference angles. So this is what we're going to be spending the rest of the lesson for 18.1, talking about reference angles. So a reference angle a couple things you should know about a reference angle. It always uses the terminal side and the closest part of the x-axis. And you should also know that it's going to be between 0 and 90 degrees. So I'm going to put a little degree symbol here. I'm hoping it comes up soon. I guess if it doesn't, if you read where it says reference angle, I just highlighted where it said terminal side and closest part. Oh, there it comes. Okay, closest part of the x-axis. There's really a delay there. So you need to be able to recognize what the reference angle is. So the reference angle uses the terminal side, which we talked about on the 18.1a notes, in the closest part of the x-axis. So if it's on the left side of the graph, it uses the negative x-axis. If it's on the right side of the graph, it uses the positive x-axis. And please, please remember, reference angle is always an acute angle. So it's always between 0 and 90. I guess it could be 0 or 90. 90 would be a right angle. 0 would be a straight angle. But for the most part, it's always going to be an acute angle, almost at 99% of the time. All right, so the rest of the notes should not take very long. We're just going to be focusing on reference angles. Any questions before I clear the screen? Okay, so let's clear this out. We're going to now go to finding the reference angle. Draw the angle and find the reference angle. Okay, so starting here, like I said, this should not take that long. I'm guessing this should be faster than the last lesson, 18.1a. So we're going to start at the positive x-axis, just like we did before. We're going to draw the angle just like we did before. So for negative 400 degrees, someone turn their mic up. Do we go up or down from the initial side?
Down.
Down. Because it's a
Down.
negative, we're going to start going down. So it goes down 90. And then every time you hit an axis, you're going another 90 degrees. So down 90, 180, 270, 360. Someone turn their mic up. Tell me, what do you add to 360 to get 400?
40.
You add 40, good. So I'm gonna go an extra 40 degrees past right here. So when I draw the terminal side, that's gonna give me a reference angle. I'm gonna do this in blue. I'm gonna call this theta. So theta is gonna be my reference angle. Let me backtrack. So theta. So theta is just a Greek letter. It's just a variable. So theta is going to be my reference angle. See how theta uses the terminal side and the closest part of the x-axis? It uses the green and the right side of the x-axis. So theta, so the reference angle here, I would say theta equals 40 degrees. That would be my reference angle. So the angle that was created using the terminal side and the closest part of the x-axis would be 40 degrees. Everyone's okay? All right, for the next one, I'm gonna do 110 degrees. So to draw the angle, this one's positive, so I'm gonna start by going up from, you always start at the positive x-axis, so you go up. What do you add to 90 to get 110? 20. So I'm going to draw my terminal side. This one's a little tricky though, because you're not using the initial side here. If you remember the definition of a reference angle, it uses the terminal side and the closest part of the x-axis. So that means it's going to use the green. This one used both of these to get theta. So this one you're using the terminal side. The closest part of the x-axis is the negative x-axis here. So this is where my theta is going to go. It always, if you're on the left of the y-axis, you always use the left side of the x-axis. So if this is 110, what do you add to 110 to get 180?
70.
70 degrees is your reference angle here. So common mistake students make is they would say, like, they might say 110 or they might say 20, because we did go 20 degrees past the y-axis, but you never use the y-axis unless it's 90 or 270. You're almost never using the y-axis for your reference angle. So it has to use the terminal side and the closest part of the x-axis, whether that's the negative x-axis or the positive x-axis. For this one, we're using the negative x-axis. All right, so last one is 710. So I'm gonna around is 360. This is gonna be 10 degrees short of 720. 720 is twice around the circle. So I'm gonna basically do 2 times around, but I'm gonna stop 10 degrees short. So this is about 10 short of the x-axis. So I'm gonna draw a red arrow. So that's how you draw 710 degrees. We did that one earlier. And then you draw your terminal side. And now to identify your reference angle, it always uses and the x-axis. So in this, it's the positive x-axis. So half the battle is knowing where theta is. So theta here is going to be right in between the positive x-axis and the terminal side. So someone with their mic on, tell me what theta equals here.
10 degrees.
10 degrees is correct, because that's saying to complete 2 revolutions, 2 times around the circle. So theta here would be 10 degrees. Because you would need another 10 degrees to get to 720, which is 2 times around. So for the last 4 problems, we're doing the same thing, we're just doing it in radians. So any questions before we go to the next page to wrap up the Zoom session today? Okay, so going to the next page, I'm going to clear the screen. We're still working with reference angles. All we're doing now is focusing on doing them in radians. So going to the next page, so this is the last page, and we only have 4 examples to do here. So we should move fairly quickly, but I don't want to move too quickly. And so this will feel like another busy week, which it is, but then after this, we're only meeting once a week. So just keep that in mind, so you can see the light at the end of the tunnel. And we'll be meeting on Thursdays, every Thursday from 10 a.m. to noon, and I'll send out another message tonight. Okay, so here you can kind of read over the stuff on the side. The main thing is, instead of saying if theta is between 0 and 90, now I'm going to say theta is between 0 and pi over 2. And it tells you in the directions. Oh, actually, it doesn't always tell you. How do you know to do it in radians? If the problem is in radians, your answer should be in radians. If the problem is in degrees, your answer should be in degrees. So if you look at 4, 5, 6, and 7, all of these problems are given to you in radians. They don't have the little degree symbol. So that means we need to give a reference angle that's also in radians. Okay, so that's what we're going to do now. So I am aware you can convert to degrees. A lot of students do this, and I'm not saying it's necessarily a bad thing, but I said earlier it's important to train your mind to think in radians. This is what's going to help you in pre-calculus. So you'll start now. It's going to benefit you later. And it'll benefit you in this class too, if you train your mind to think in radians. So rather than converting to degrees and then at the very end having radians, you can check your answer that way while you're getting used to working in radians. But as I do these, I'm going to show you how to think in terms of radians rather than just convert to degrees and then convert back at the end. Okay, looking at 4, 5, 6, and 7 here. And this will be it for today. So if you're thinking in terms of radians, every time you have pi radians, that's halfway around a circle. So I'm going to convert these to mixed numbers. So you guys remember in middle school, you learned to convert to a mixed number? So right here, I'm actually going to start off though by highlighting the positive x-axis. So I always remember where to start. You always start here, you're finding a reference angle. This is the positive x-axis, right side of the x-axis. Okay, so for number 4, I'm going to convert this to a mixed number. Whoops. So when you convert this to a mixed number, 7 divided by 4, 4 goes into 7 one time. 4 times 1 is 4, so you have 3 left over, and then the denominator stays the same. So this is 1 3/4 pi. You can think of this as 1 pi plus 3/4 pi. So 1 pi is going to look like this. It's going to go 1 pi is 1 semicircle. You're going up from the positive x-axis because it's a positive measure. So this would be 1 pi halfway around. And then 3/4 pi would be 3/4 of a semicircle. So this would be 3/4 of a semicircle right here. So we just did 1 semicircle, and then we're doing 3/4 of a semicircle. And this would be 7 pi over 4 radians. So think of 7 pi over 4 as 1 3/4 pi radians. So this is going to look like this. So theta here is going to be the angle formed using the same side of the x-axis and the terminal side. So theta, if you want to complete pi, if you have 3/4 of a pi, aren't you missing 1/4 of a pi? So in order to complete another pi, you would need another pi over 4 radians. So that's what theta equal. So think of pi as half a circle. So you need another 1/4 of half a circle to make it all the way around. So theta here is pi over 4 radians. That's what you could add to 7 pi over 4 to get 2 pi, which is a full circle. Okay, for this next one, on number 5, it's a negative measure. So that means it's going to go down. So you go down 5/18, which is about here. So that's about 5/18. That's pretty close. 5/18 is pretty close to 1/3, a little bit smaller. So it's about 1/3 of a semicircle. And then the terminal side is going to look like this. From the origin, passes through the arrow. So theta is going to be this angle right here. That's the reference angle. And remember, the reference angle, a little bit earlier, it's cut off, but it's always between 0 and pi over 2. So in this case, it would just be how far we went down, which is positive 5 pi over 18. So we just have 2 more to go, and then we're done. Any questions so far?
How do you know how far you go down? Like from the
Here, so just think of 5/18. That's between 1/3 and 1/4, right? So 5 over 15 is 1/3. 5 over 20 is 1/4. So you just go about 1/3 or 1/4 way down, 1/4 of a semicircle. So this would be an entire semicircle. You're just doing about 1/3 of that.
Okay. That makes sense.
Okay.
Wait, I have a question too. Will theta always
All
be
right.
positive?
Theta will always be positive, yes. So theta is always between 0 and pi over 2 for radians. So this note here that you can probably see, but it's cut off on the screen. Now I don't want to move anything. But it says theta is between 0 and pi over 2.
And then
Okay, so number 6.
Mr.
Oh, go
Morris,
ahead.
how do you find theta again?
Yeah. Theta is just the angle formed using the terminal side where you stop and the closest part of the x-axis. So we'll do 2 more of those, and then I'll talk about those more as we go through 6 and 7.
Okay.
How to find theta. So this one is 7 pi over 3. So I'm going to rewrite this. I know this is a long day. Like I said, this is a long lesson. It's 2 hours on Zoom is tough, but like I said, hopefully you can see light at the end of the tunnel here. So this is going to be when I change this to a mixed number. This is 2. 3 goes into 7 twice with a remainder of 1. Denominator stays the same. So you could think of this as 2 pi plus 1/3 pi. So 2 pi is once around the circle. And then you're doing 1/3 pi, which is 1/3 of a semicircle. So you're going 1/3 of halfway around the circle. So about right there. So how do you know where the reference angle is? The reference angle uses the terminal side, which is always in red, and the closest part of the x-axis. Because we're on the right side of the graph, we're going to use the positive x-axis. So theta is going to be this angle right here. Oops. This one uses the red part and the yellow part. It won't always be the red and the yellow though. Sometimes it uses the negative x-axis. But it always uses part of the x-axis, whichever part is closest. So can somebody tell me in radians what theta equals?
1/3.
It's what? I thought I heard it.
1/3.
1/3 what?
Pi.
Pi.
1/3 pi. I'm going to write 1/3 pi is pi over 3.
Wait, why is it 1/3 pi?
Because 1/3 pi is how far we went past the x-axis. So we went 2 pi all the way around, and then we went an extra 1/3 pi to go from the yellow to the red.
So it's always like the remainder you need, or like how much more you went, right?
It's either how far you went past or how much more you need. It just depends
Oh,
on
okay.
it depends on which quadrant.
Thank you. Okay.
But it's always using the terminal side and the closest part of the x-axis. Because to make an angle, don't you always need 2 sides? So one of those sides is always the terminal side. The other is either the positive x-axis or the negative x-axis, whichever one is closer. So on this next one, we'll look at one now with the negative, where it uses the negative x-axis. So first thing I'm going to do here is I'm going to write this as a mixed number, so I'm training my mind to think in radians right now. So this is -3 1/3 when you convert 10 over 3 to a mixed number. So you could think of this as -3 pi minus 1/3 pi. So because it's negative, I'm going to start by going down. So this is down 1 pi. This is down 2 pi. Down 3 pi. And then we need an extra 1/3 of a pi. So this would be 1/3 of a pi right here. So now I am going to use highlighter. It's going to look like this. And to identify where theta is, it uses the terminal side where we stopped and the closest part of the x-axis. See how this one, we're on the left side of the graph? This is the first one we've done on this page where we stopped on the left side of the graph. So you have to use the negative x-axis here. So my theta, and the hardest part of the problem is just defining where theta is. So theta, you have to use your mathematical skills here to figure out what angle theta would be. Can someone tell me? How many radians?
Wait, it's
1/3 pi? Or?
yeah, 1/3 pi.
1/3 pi. Good. So didn't we go an extra 1/3 pi past the x-axis?
Mm-hmm.
So I'm gonna write that as pi over 3 here. So in this case, remember, it's always between 0 and pi over 2. It forms, it's like an acute angle between 0 and 90 degrees. So here we have pi over 3, using the negative x-axis on the term side. So any questions here?
If the radian stopped at the x-axis, what would the answer be then?
If it stopped at the x-axis, it's a good question. And if it stopped at the axis, then it would just be 0 degrees. If it stopped at the y-axis, then it would be, or I should say 0 radians. If it stopped on the y-axis, it would be pi over 2 radians. It would form a 90-degree angle if it stopped at the y-axis.
I'm done.
With the x-axis.
That was the last problem.
Okay, any other questions?